Hi, welcome to my latest video. Today I'm out here in the nice September autumn sunshine and I'm going to be starting my catch can upgrade. So a few years ago I fitted this little blue oil catch can. It actually says oil catch can on it there. And I'm going to be upgrading that to this bigger, better one. So this one not only has a nice stainless steel gauze to collect the oil, but it has a pressure relief valve built in, and it even has a drain on the bottom. Okay, so I'm going to be fitting a little valve with some hose. I've got an assortment of bits of hose here. I don't quite know what length or size, diameter I need, but I'll be fitting that on the bottom there so that I can drain out any oil that is collected. I've been designing a new bracket. Okay, so these are 3D printed in ABS. This is probably the one that I'm going to go for. This was my first prototype here. I'll talk more about the brackets, the new brackets, in a moment. The old bracket is here, and this one, even though it looks 3D printed, is actually cast in polyurethane, because back when I designed that I was 3D printing in PLA, and PLA melts at about 60 degrees, so it's just no good for the engine bay. So what I was doing was 3D printing the design and then casting around it to make a silicone mould, and then using that mould to then make an identical item out of hard, rigid polyurethane, which can take over 100 degrees. That is the technique that I use for my air horn bracket here. I still make those out of polyurethane. I'm still selling those on my website, beavispits.com, but I've stopped selling these, okay, because I want to focus on the new can, get this fitted, and if it works, then I'll be selling these brackets. I don't know if I'll be selling them as ABS or polyurethane or what. Just need to get it fitted and see how well it performs, really. I've also got my whiteboard out. I'll do a very quick lecture, very quick drawing on what is a catch can. Why do you need a catch can? What does it do? Pit Lane Kitty's out here. She's going to help me do this, and I'm going to get this fitted. Now I've got my camera on the handheld thing, I've got my tripod here as well. I'll be switching between the two, okay? So let me start off by explaining why a Freelander 2 needs a catch can. Okay, so this blue silicone ducting is my air intake duct. Yours will probably look different to this. You'll probably have a black sort of black rigid kind of plastic duct, possibly with some little resonant chambers on it. Okay, so those chambers were done to, they're called Helmholtz resonant chambers. They were fitted to reduce intake noise. They didn't work, and Land Rover actually got rid of them on later models. Okay, on mine I removed the duct because this joint here, where the factory duct joined onto this black pipe that goes down and into the turbocharger, was leaking a lot of oil. You can still see the remnants there. I've never actually cleaned that up, and I'll do that as part of this project. Okay, so I'll give that a good clean. Oil was leaking there, and it's a really common problem. You get this oil leaking, and it goes down, and directly below that is the red hot turbocharger. So you get this stink of burning oil, and you get smoke, and yeah, it kind of enters the cabin, and it's not very nice. Okay, mine was doing that, and I thought, right, I've got to sort this out. So replace the duct to stop the oil dripping, and of course when I replaced the duct, I then couldn't use the factory pipe that comes up from a thing called the PCV valve, which is a thing there. That's what lets the blow-by gases out of the bottom of the engine. That, as standard, has a little short black hose that connects back into the factory duct. So I needed to replace that with this little aluminium hose joiner here, a bit like this one here. So it's just got a little branch sticking out the side of it. Okay, so that one's got a 13mm, I think it is, stub sticking out. And rather than route the pipe straight round and in, I took it to an oil catch can, so that any oil in those fumes would be removed or partially removed. It's not working as well as I wanted. Okay, these cheap catch cans, they don't really have like a sort of gauze inside. You can add your own filter, you could even add something like wire wool if you wanted to, but it just doesn't have that kind of surface area inside to allow that oil mist to condense and drip out. Another problem with these is they're a bit fiddly to empty. You have to sort of unscrew the bottom part of the can, and it does actually come with a little dipstick, which is nice, and the new one doesn't have a dipstick, which is a little bit of a negative, but with the drain on the bottom I can just drain off every now and then. So there's the dipstick. Now I did empty this not so long ago, a few weeks ago, so we've got a bit of oil. There's a little bit of oil on the bottom there. It's not too bad, okay, but I have had a couple of times where I've forgotten about it, and after a couple of months I've gone to empty it and the thing has been really full of oil. The worry with that is if the can fills up and the blow-by gas can't get out from the bottom of the engine, there is a danger that it could actually blow the seals out at either end of the crankshaft. Okay, so there's what they call the front and the rear seal. I mean, it's not actually front and rear, it's left and right, but there is a seal at this end on the crank pulley that drives the timing belt, and there is another seal behind the clutch. When I had my clutch replaced recently, the mechanic who I got to do it, because it was just too big a job for me to do myself, the mechanic took the old clutch off and he said that it had begun slipping because of oil contamination. Here's a photo actually of the old clutch plate and flywheel, and you can see that there has been oil sort of spraying about on it. Okay, so the actual friction plate, he said, could have actually gone on for probably another 30,000 miles, but it had been contaminated with oil. So I don't want to go through that again. That cost me £1,300 to get the new clutch fitted. I got the seal in the end of the crank between the clutch and the engine. I got that seal replaced, and the slave cylinder, the flywheel, everything. It was a major job, and about 7 or 8 hours of labour to actually do the clutch replacement. Okay, very big expensive piece of work, not something that I could do myself, so I just had to put it into a garage and get that done. So it's really important that the blow-by gas from the engine is not restricted in its flow out from the crankcase. Okay, you mustn't build up any pressure in that crankcase. So what most manufacturers do is to take the pipe carrying the gas out from the engine and they duct it back into the intake. I'll get the whiteboard out now and I'll do a very quick diagram which should help to explain things a bit better. So we have an engine, okay, so here's an engine. Right, I'm just nice and simple. That has a cylinder head here, the head gasket, and then this is the engine block. On the bottom is a sort of sump where the oil sits. In there is the crankshaft, okay, and that has a sort of kind of thing like this with the big ends, okay, and then a con rod up to the little end with a piston, and that sits within the cylinder, okay. Up the top we've got some valves. Okay, I'm not going to draw a 16 valve or whatever, this is just a in. So this can be the inlet here, the duct coming in, and this can be the exhaust here, which goes off down out the back of the car. Okay, there's the combustion chamber, and this piston has some rings on it. Okay, so there's usually 2 compression rings and 1 oil control ring. Okay, so that oil control ring is usually sort of sitting below them. So I need more colours really here, but I've got a red pen now, so let's just draw the inlet charge coming in red. That goes in, and there is combustion in here. Okay, piston goes down and then comes back up, and then when the other pistons go down, and pushes out the gas down the exhaust. Okay, 4-stroke cycle, draws in, compresses, ignition, and then exhaust. What can happen is, due to the high pressures in here, especially on a diesel engine where the compression ratio is much higher than on a petrol engine, is you get a little bit of gas going down the sides of the piston. Okay, so especially on older engines where the piston rings are a bit worn, you're going to get a little bit of gas going past, and that gas can build up down here in the crankcase. Okay, so that's the bottom of the engine, the sump. It's the part of the engine below the pistons where the crankshaft is spinning around. That crankshaft has a lot of oil. Okay, so these are plain bearings. Okay, they're not ball bearings or ball races. They are called journal bearings. They're just literally metal shells, and the big end on the crankshaft is separated from the crank here is separated from the big end on the conrod. This is the conrod here, by a film of high pressure oil. Okay, so this is why if your oil light comes on, do not drive any further, because the minute the oil pressure drops, you're grinding metal, and when your big end bearings go, you end up with a really noisy, clattery engine, and it's going to be going to the scrapyard pretty soon after. Because of this high pressure oil around here, and also around the main bearings, which are the ones with the sort of kind of clamps, the bridging clamps that kind of hold the crankshaft in place, they also have oil ways that deliver oil in high pressure. There's a lot of oil mist floating around here. Okay, a lot of oil mist. As the engine spins at high speed, it sprays oil all over the place. That oil mist wouldn't really be an issue if it weren't for this blow-by gas that's getting past. Okay, because if there was no blow-by gas, that oil mist would just eventually condense down into the oil in the bottom of the sump, and there's an oil pump that then takes it back round through all the oil ways back to the crankshaft and all of the other parts of the engine that need lubricating, the camshafts and various other moving parts. Because of this blow-by gas that gets down past the pistons, pressure builds up in the bottom of the engine, and eventually you're going to end up with oil leaks coming out wherever there's any gaps. So where this sump pan is bolted to the bottom of the engine, where the crankshaft comes out at either end of the engine, or either side of the engine if it's a transverse engine. So you've got a pulley running on one end and you've got the clutch spinning on the other end. There are seals around the end of the crankshaft. if there's high pressure building up in here with all that oil mist, you're just going to get oil leaks coming out all over the place. Very, very early cars originally didn't really have any kind of ventilation on the crankcase, and they soon realised that it was really not working, okay, because oil was getting out past the seals and coming out everywhere. So what they did was they just vented it out to atmosphere, okay, and that was alright for a while. We were driving around on gravel roads and nobody really cared if you dropped a bit of oil on the road. Then as they made tarmac roads, people started to complain a bit about the amount of oil that was being dripped out of these engines. So they thought, right, okay, we'll have to send it somewhere, okay. So one option was a thing called a draft tube. So they just took this and sort of made like almost like a second exhaust. It was just a pipe that kind of stuck out under the engine, and as the wind blew past the end of that tube as the car went along, it created a little bit of low pressure and it sort of drew out that oil mist, but it was still coming out onto the road. It's still not ideal. Some car manufacturers tried to put it into the exhaust. That just didn't work, okay. It just didn't work for two reasons. One, if you put any kind of silencer on your exhaust here, you're going to get a bit of back pressure building, and also you can get backfires in the exhaust, okay. So pops and bangs as such, because of the unburnt fuel that's going down the exhaust. Certainly on old cars, it used to backfire all the time. You get a backfire, suddenly very high pressure blasting back in, and this oily mix in here can be quite flammable, so you then explode the sump. So that wasn't going to work either. So another solution was required. So what the manufacturers did was to take it back into the intake. So let's get rid of that, let's get rid of that, and they fed the exhaust gas, or the blow-by gas, up and into here, okay, so that the gas would come out up here and back in, and then it would get reburnt. Not ideal, that, because that gas that's coming up from the bottom of the engine has already been burnt once already. It's got a lot of inert compounds in it. There's not a lot of oxygen. It'll be nitrogen oxide, carbon monoxide, plus there's all this oily mist, which, do you really want to burn that? It probably wouldn't do any harm, but it's going to make a bit of smoke out the back. It's not ideal. So that worked for a while, and what happened then was that where this, on a petrol engine, you've got a throttle butterfly here, okay, and what was happening was when you decelerated and you engine braked, you took your foot off the pedal and the throttle butterfly would close. These pistons were still sucking air in, trying to suck in gas from the intake, and a very high vacuum would build up in the inlet, and that would then draw vast quantities of gas out the bottom of the engine. And the problem with that is the seals, rather than the seals being blown out, the seals could actually be sucked in. You'd end up with air going past the seals coming in, which would froth up the oil. That just wasn't really working. So some car manufacturers fitted a air intake valve here, drawing air in, okay, from the atmosphere, and that air would then ventilate the crankcase, positively ventilating the crankcase with fresh air coming in, adding to what's in the crankcase. Hence, positive crankcase ventilation, PCV. A lot of people get it wrong. They think the PCV is some sort of vacuum control valve. On this side, it's not. The original PCV was a ventilation into the crankcase to prevent that vacuum building up. Nowadays, everybody talks about a PCV valve on this route here. Okay, so we don't really have this anymore. Okay, that's gone. That was what they used to do on old, you know, sort of V8 engines and things like that, where you had to have this ventilation flowing through the crankcase to replace the blow-by gas that was being sucked out under engine braking, okay, and prevent a high vacuum building up. So what car manufacturers do now is they put a valve here, and this has a sort of diaphragm with a spring, and what that does is it limits the amount of vacuum applied to the crankcase. Okay, so it is a vacuum limiting valve. Everybody calls it PCV. Technically it is a CDR valve, crankcase depression regulation valve. Okay, so it means that when you close the throttle body and a high vacuum builds, this valve limits the amount of suction being applied to the crankcase. Okay, so that is what modern day cars call the PCV valve. Okay, it also protects against backfires, but not backfires at the exhaust. You can occasionally get a backfire sort of coming up the inlet, and of course you wouldn't really want that pressurizing your crankcase. So the valve in here is designed to limit the suction, but it also closes up if a positive pressure builds. Okay, on the diesel engine, this Land Rover diesel engine, it is like this. Okay, however, on a diesel we don't have this. Okay, there is a throttle body. I know there is a throttle body with a butterfly in it, but it's not a true throttle control valve. It's called the air control valve. Okay, and the diesel, basically think of it like a door that is open or closed. Okay, it's open when the engine is running. It closes the minute you turn off the engine, giving a rapid shutdown. And it also, I have read that it will open, it'll close a little bit to encourage exhaust gas recirculation. Okay, this whole diagram is nothing to do with exhaust gas recirculation. That is a completely different thing. That takes some exhaust gas back round into the inlet to cool the inlet charge to reduce nitrogen oxides being created. Okay, it's all done for emissions reasons. All right, EGR, totally different to PCV and crankcase ventilation. All right, so this is I'm going to call it PCV, even though it's not a true one, but it really is a CDR, crankcase depression regulation valve. Nothing to do with EGR. I've just put EGR on the diagram so that you can see what EGR is. Now, of course, for this EGR to work, there needs to be a slight vacuum here, and that's one of the things that the throttle body, the air control valve on this Land Rover diesel engine will do. It will close a little bit to build a little bit of a vacuum, because don't forget, here we've got our air filter. I'll show that as a sort of fluffy cloud, as a sort of foam or paper air filter, and because the engine's drawing in that air through the filter, you'll get a slight negative pressure. I'm not even going to use the word vacuum. It's not a vacuum. Okay, the vacuum on this car that's used for brake servos and that is actually generated by a vacuum pump. Okay, because there is not enough vacuum anywhere else on the engine to do things like that. So this here isn't really a vacuum. Even when that valve closes very slightly to promote the EGR flow, it's still not a proper sort of vacuum to cause an issue really, and need this PCV valve to kind of start closing and limiting the flow. Okay, so I will do more videos in the future on the throttle body, as we call it, on this engine. I'm actually going to kind of connect up two throttle bodies in parallel and motorise one while the engine runs on the other, so that we can film what's going on with the butterfly as I drive along. Okay, so be an interesting video, but that's not for today, that's another time I'll do that. So this valve here, PCV as it's going to be called, doesn't do that much on a diesel. It's really there just to limit that vacuum if required. If the air filter got blocked, for example, if the air filter got blocked up and the vacuum started to build, then that could present a problem by lowering the pressure too much in the crankcase. Okay, so that's really there as a safety valve, as a vacuum limiting valve, and should there be any kind of backfires up here, it'll protect against that as well. Okay, so where is it on this engine? The PCV valve on this engine is this thing here, a kind of diaphragm and a spring kind of assembly. Okay, so there's the gas kind of pushes up. When it reaches a slight positive pressure, it will open the diaphragm and vent out, and it vents up that little pipe there, not this big blue one, this little pipe there. Let's try and zoom in. There you go, you can just see it there. Okay, there's a sort of a right angled bend on it and a pipe. I didn't even bother putting a Jubilee clip on it because there's not going to be any high pressure in that at all. Okay, so that comes up. Let me just move my tripod out of the way. Put my handheld thing on, and it is down there. Okay, and it goes into the catch can, which hoses it. This one here, catch can removes as much oil as it can, and then goes back out and back into here. When I first fitted this catch can, quite a few people said, it's not required, you know, that oil is needed by the engine to lubricate valves and various other things. Okay, valve guides and inlet valves. Okay, I've been running like this for 4 years, maybe 5 years, not had any issues at all. Okay, there's still a small amount of oil in the gas that comes out from the catch can, and there will still be a small amount of oil in the gas that comes out from that catch can. It's similar to the amount of oil that you would get in the blow-by gas of a new engine, okay, without much wear on the piston rings. Okay, so that oil can't be by design, but likewise you can't just dump it out onto the road. Okay, it's going to be there, especially on higher mileage engines. You've got to do something with it. The obvious thing is just to stick it back round into the inlet. Got to be a bit careful though, because not only are you going to be putting inert gas into the engine in the inlet, okay, so engines like to run on air and fuel, not carbon monoxide and nitrogen oxide and all those things that have already been burnt once already. So putting inert gas in is going to displace some of the oxygen, okay, because it's going to take up volume in your inlet gas, and less air means less oxygen. Okay, so performance is going to suffer a little bit, but also that oil that is going to be coming up here will be then going along here, down there, through the turbo, round, through the intercooler, and up and into your throttle body, coating the manifold absolute pressure sensor, the engine temperature sensor, or the engine air temperature sensor. Okay, so I've seen many throttle bodies where they are black as anything inside. They're just caked in a thick black greasy sludge, and it's a real mess inside there, and the inlet manifold and the intercooler are going to be in an equally bad state. Do you really want all that oil going through all of those components of the engine before it actually goes in and then gets burnt, creating a stink out the back of the car? It's not ideal, really. It's not ideal. You can't just dump it out onto the road. I mean, you could. It will probably fail the MOT. It's not great to drop oil on the ground. It can be really, really dangerous for other road users. In particular, motorcyclists are going to hit that oil and come off. Okay, so we need to do something. And the best thing that we can do is to catch that oil, catch as much as possible before it's put back into the engine. And then, every now and then, you just have to drain off the oil, okay? So what I'm going to do in a moment is I'm actually going to take the bottom of this off. And I'm also going to take this ducting out. And we'll see what sort of state they are inside. We'll see how much oil is collected and what colour it is. Is it clean oil, or is it really, really black gloopy oil? Is it just oil? Is there any water in there? Is there any metal particles in there? It's kind of interesting to see what gets caught by these catch cans. And the new catch can's got a nice stainless gauze in it, so I'm hoping that will capture a lot more oil than this other little cheapy one. When I remove this, because I'm going to take all this out, I'm going to take all this, all these hoses, I'm expecting this pipe here to be clean to about there, and then it's going to be really black inside, because this pipe here is going to be injecting all that grot back in. Now, in my last video I actually crawled around under the car and investigated an oil leak. My car has been dripping oil lately, and some of it is coming from the gearbox, some of it is coming from this duct. Okay, so down the bottom there, where the elbow hose that comes out the bottom of the turbo, it's got clearly a sort of a line of black oil running down it. It's not coming out of the turbo. Okay, so the turbo oil seals are fine, and if the turbo oil seals were leaking inside, that would be contained within the hose. Okay, there's no evidence of any oil on the outside of the turbo, so the only possibility is that it's kind of coming from up here somewhere. So I think it's where this duct here joins on to the input of the turbo. There's a Jubilee clip there, and I think it needs tightening up or something, because there's definitely an oily stain around there. I'll put up a quick screenshot now from last week's video which shows that oily stain. Okay, so one thing that I have considered is actually extending this blue silicone round the corner and down, and then sort of onto the turbo. I'm not sure whether or not I'm going to do that or not. Okay, so this duct, I have no idea what size it is where it goes on the turbo. I'd have to take the wheel off and kind of get in and have a good look at it. It wouldn't be too difficult really to replace this with a slightly longer pipe. This is a 300mm. I could put a 400mm and then take a sort of elbow like that one down, and then another pipe. Don't know how long that would need to be. Probably this one actually could be used down there if that one's being replaced, and then another elbow going in at the bottom. Now, just in case you're interested in replicating this, I did a whole video on this. Okay, it was like an hour and 40 minutes long, and in the video description is a complete list of all the hoses, the sizes, the clip sizes, everything that you need to replicate that setup. Okay, I won't go into all the details now, but it's a 70mm hose. Okay, 70mm, and this bend must be a 60-degree bend, not 45. It kinks up at 45, so it's going to be 60-degree, and they're quite rare, difficult to get hold of. So this company, Auto Silicone Hoses, okay, are really the main people to look up on eBay. All of these hoses were from them, not the catch can, that was from Amazon actually. It's quite clearly made in China. Guard against bee entangle in turning parts. Stop the engine before check or maintenance. Okay, yep, fine, kind of common sense stuff really. So yes, it's made in China, but so's the other catch can. There is actually one available which might possibly be made in the UK, and well, there's two actually. One's called a Pro Filter, I think it's called. Pro Sport or Pro Filter, Pro something anyway. And there's another one called a Man Hummel filter. And they look exactly like these. So I don't know if this is a cheap Chinese copy or whether the other ones are actually the same item but just sold like twice the price with a different name. I'm not sure. This one looks perfectly good to me. Perfectly good. We've got the nice stainless gauze. Let's just take it apart a bit more. A quick look here. So we've got this here. Now on mine that has kind of come off, and I don't think that was actually meant to come off. It's meant to be kind of clipped in. So I might need a little bit of glue just to clip that in. Oh, there we go. Hang on, I have to clip it back in now. We've got our sort of gauze thing here. Okay, so this is the thing that actually strains out the oil, collects the oil. And so let's have a look. So we've got an arrow there. So that's the intake. These are 25mm diameter kind of intakes. These red things are just covers. Okay, so they come off, keep dust out or whatever. And goes in, spirals round, so a bit of centrifugal force there doing its thing through the strainer, and then because that is on this side, not there, it doesn't sort of spiral and then out. It's almost like forced to do a U-turn halfway down. So I'm guessing it spirals. It's kind of like one of those cyclonic vacuum cleaners really. It spirals it down through there and then spirals the other way to get out. And yeah, how's that going to work? Yeah, okay, so this sort of thing here that's got a seal on it. So yeah, so it comes in, spirals one way down through there, and then it's forced to kind of start spinning the other way, and by forcing it to change direction at high speed, it throws out all the oil. That's the idea really. So it goes sort of spiraling down out through the gauze, makes a U-turn, goes the other way, and then goes back out of that other hole and back out of here. Now this thing here is some sort of pressure relief valve. Not totally sure what that does really. Yeah, let's just see if we can take that cover off. See if I can get there. That doesn't come off. I'm not sure. I think inside there's something down in there. If the pressure builds, I'm not actually sure what actually happens. Does it vent out under that, or not sure really, but somebody went to a lot of trouble to design that thing on there, and there's a sort of like a diaphragm and a spring. When I come to fit this, I'll try and take that apart and see if I can actually see how that would work. But that was one of the features that I saw which made me think, oh, this is quite good. You know, it's got a pressure relief valve. It's got this nice, lovely stainless mesh here. That's actually like double layer stainless gauze. That's nice, nicely built, nicely done. And then you've got this kind of drain hole at the bottom here, which I think is a 12mm. I can't even get that thing off now. So I bought some hose. This hose, I think it was this bit of hose here, this is an 11mm hose. Okay, I just decided to go 1mm sort of tighter, just to give a good seal onto there, because I don't want like loose fit, because this is going to be like all the crappy oil at the bottom of the thing. It's going to be under oil as such. Okay, so I don't want it leaking out anywhere. So we'll have a bit of hose, and then we'll have our little tap thing. It's like a little kind of gas tap thing, ball valve there, and that can just sit clipped low down under the car with a bit of pipe, and then every now and then I just come along and, well, no, that'll be closed, yeah, and then I open it and oil pours out. Right, okay, that's enough talking. I am now going to start dismantling all of this. Okay, so I'm going to start taking out the airbox, disconnecting these hoses, and I'll put the camera on the tripod while I work on that, get that all taken apart, get rid of the old catch can, empty that, well, open that up and empty it out and see what's in there, and then we'll start looking at brackets. Okay, so this was a bracket that I made to kind of hang the new can in the same place as the old one. I've since then decided to try and move it over here. Okay, so I was going to bring the hoses down around a corner and in, but now I'm going to just bring them straight down and put it there. Now this thing here, this is actually the air filter for my Webasto, so that could then move over here once this can's gone. Okay, keeps it closer to the Webasto then. So that's the plan, and the sun is starting to kind of go down a bit now. It's getting a little bit evening-y. So what I'm going to do, take some of this apart today, and then I'll get up bright and early tomorrow. It's going to be a nice sunny day again tomorrow, and I will start looking at bolting this in with various bits of hose, and then go for a drive and see if it catches anything. Okay, so here we are the next day, and I'm going to start disassembling this now, removing all this ducting here, the air filter box, the old catch can, all the hoses that go with that. It's a bit cloudy and quite windy today, so I've put the camcorder up here. I've got the furry rat on the microphone here, pointing forwards, because I'll be sort of here working here, and I've aimed the camera sort of at a kind of aerial shot, or really of the whole engine bay. Okay, so I'll be working here. I've got my cup of tea ready, I've got my socket set, and yeah, let's crack on. I'm going to switch across to the camcorder now, and I'll talk you through each step of the disassembly process. Okay, so first things first, let's remove that, and I need to get this out with that duct. I'm probably just going to take this, I'll undo that, because this bit's clean. See, if I just lift the whole thing out, it's just going to pour oil everywhere. Okay, so I want to have a look inside this ducting as I remove it. So let's take this off, which is the mass airflow sensor plug. Mustn't forget to put that back on. Let's put that sort of out of the way over there somewhere. This whole airbox, it looks a bit loose, but that's deliberate actually. It actually sits on some rubber mounts, so that as the engine moves below it, this, I don't know, can move separately. So let's undo this one here. 13mm socket on these Michelor clamps. So what I'll do is, even though I've put all the clamp sizes in the description of the video I did when I first fitted this, I'll talk through the clamp sizes as I go. So it's 70mm 60 degree hose here, 60 degree elbow, 90 degree elbow there, 70mm, and then 100mm straight joiner hose there. This piece is 300mm long aluminium hose joiner, and there's a 100mm one there with a, I've got on this setup a 13mm stub sticking out, okay, so a little branch coming out the sides. Now that is going to get replaced with similar item with a 25mm, okay, because the new catch can uses much bigger hoses. So let's separate this up. These clips here are Michelor W4, so the marine grade stainless. We've got a, what does that say, 79 to 85, and they're all 79 to 85. Okay, now this will be really interesting to see what state this is in on the inside. Right, come on. Okay, right, now let's have a little look. Okay, so that is clean and bone dry, but there's a couple of little spits of black oil there, which I think have just sort of come back outwards slightly. So that's got K&N air filter in. It's also got this rubber diaphragm there. It's a actually a cistern, I think it's like a toilet cistern diaphragm washer thing from Homebase. Did a separate video on that, Hole of Doom video, okay, because if you don't have something there, if you go wading, water's going to get back up and it'll go into your engine and wreck your engine. Okay, I've seen it happen. So yeah, watch that video, Hole of Doom, airbox drain hole, I think it's called, something like that. One of my most popular videos. Okay, so that's out. Now something fell down there. That is my air filter airbox adapter. Okay, so if you've got a snorkel fitted, you can buy one of these on my website, beaverspits.com. That's actually made out of hard polyurethane. It's not 3D printed. The original item was 3D printed and made a mould and cast that. Okay, £20, you can buy one of those if you're fitting a snorkel, or if you want to get rid of the horrible cardboard ducting that Land Rover fit and replace it with nice silicone pipe, which is what I'll be doing very soon, as well as finishing my snorkel project, which is still on the back burner after many years. So what I'm noticing here, I don't know if you can see that, but this here is fairly clean, but just over there it's black oil. Right, yeah, I can see in there that's black as anything. Okay, right, the rest of this duct can come off now. So 13mm on. I'm going to come around to the other side. Now this is loose. That's not right. The cam belt cover here is supposed to be bolted down. So while this is all off, I'll find a suitable bolt and make sure that's more secure. That was quite a loose fit. I wonder if that's what's been causing my oil leak. I don't know whether to get rid of this soundproofing. It's in the right state. I'll try and get rid of that. Right, okay. Let's have a look in there. That's pretty bad. Okay. There is oil sitting in there. Black oil. Okay, and that's what's been going through the engine. That's after the catch can, okay? So that's after the catch can has tried to remove some oil. Its leftovers are visible there. There's only a little bit of it, the rest of it went through the engine. Right, so I need to put this somewhere where it's not going to make too much of a mess. take the catch can off with its bracket in one piece. Right, now I've got to be careful because this is going to drip oil. Right, now we have one old catch can. Okay, so this is the model of catch can that I was selling a little while ago with my bracket that I designed. Okay, this bracket is not 3D printed, it's cast polyurethane, and it's held up pretty well. There's a slight bit of warpage right at the top there. That's just where the hoses have been constantly sort of bending it. That's bent slightly there, but it's there. The catch can is there. What I'm going to do is, if I undo this, I've just got to remember this has got a load of oil in it. Okay, so I'm going to just undo those two Allen bolts on the back, and then we get the can off. Okay, right, there's the bracket that can go in the bin. Okay, here we go. Right, so all of you who say a catch can is not required on a Freelander 2, look away now. Yeah, there we go. It's about a quarter full with black oil, and I emptied this not so long ago. This is the strainer on the old can. It's literally just a plate with some holes drilled in. It's not going to do much at all. So it's no wonder that this can was not really removing much oil from that blow-by gas. Okay, so yeah, you get what you pay for, really. The new cans are about £35 each. These ones are about £15 to £20 each. Okay, I think this bit here actually may unscrew. Yeah, it does. So look at that. You can unscrew that and stick some wire wool or something in there. Okay, why didn't I think of doing that? Never mind. Too late now. If you've got one of these cans, you might want to check yours and stick something extra in there, just to add a bit of surface area to cause more of that oil mist to sort of precipitate out, drip to the bottom of the can. So this is a very long version of the hose that I'm going to be fitting. So I'm just going to take the reducer off. Okay, so there's the 19mm end. So that obviously will be cut down. That's going to go like that, and let's have a think. So yes, that needs to be high up because the inlet on the can is at the top. Now, if that was to go round down there, yeah, it's just not going to be at the right angle, is it? I can't really bend that like that. It's just going to kink. So what I'm going to do is I'm going to leave that piece there, even though it's a bit loose. I'll leave it there, put this on, and then I'll see if I can get probably a 90 degree, or even a whatever the next size is, 135 degree kind of reducing bend to come out there, either up or even better, sort of all the way up and round. I don't know if they do a 135 degree reducer. Not sure, I'll have a look. I definitely would do a 90. Okay, so what I need to do is I think the next thing to do really is to actually fit the new catch can in place. Okay, because otherwise I'm going to have all these pipes, and yeah, I need something to connect them to. Okay, so what I'm going to do is remove that. That's my Webasto air duct. Okay, there's the catch can, and we've got two brackets here. Okay, so the first bracket was my original design, and that would have the catch can kind of sat on it like so, okay, just hanging kind of there, and then I would put two 90-degree bends on there going off to the feed and return pipes. That's how things were going to be until I installed my Webasto, and then I needed an air filter, and I need room for a few other things like a control box and things like that. So what I'm going to do now, I'm going to turn it that way, and I'm going to mount it quite a bit over, not with that bracket, but with this one. Now I've got to get this right, it goes that way round. Okay, so this bracket will sit like so, and there's a little cutout at the end just for the fan. Now what I'll do, if I move the tripod around while I do this, I'll move it round and then you can see what I'm doing. Right, okay, there is the catch can on the bracket, a couple of stainless bolts, washers and nuts, nylock nuts on there. That is nicely in place. So what I need to do now is try to mount this. Now I'm a bit wary of this thing. This is the like coolant vent pipe from the thermostat outlet. Break that, kink it, or wear through that. So that will just sit nicely like so. So let's get this top bolt in. And the idea is that it's only attached at one end, and the other end just sits nicely on top of the radiator housing, or the fan housing. Okay, through there, because there's just nothing to bolt to over here. Just a chunky, solid print ABS bracket. Okay, right. It's in there. It's in there. It's in. It's pretty solid actually, that's good. Now, it's not sitting quite as solidly on top of this fan housing as I wanted. I'm going to disconnect the camera so I can show you. Okay, so this is, let's just zoom out a bit. Right, so here's the bracket, here's the top bolt there, L-shaped bracket. But the issue is here. This is just, so I've got the kind of in there. It's here. It was meant to be sitting here, not here. Okay, so that was meant to be back a bit, sitting like kind of like so, on top of the fan. Difficult for you to see that really, but it's kind of a little bit mid-air, but it's fine. It's not going anywhere. But I might need to thicken up the print backwards here, so this bit here is thicker and supporting, pressing nicely onto that. Okay, but that's in. Coolant hose is quite happy there. I might have to put a bit of sleeving around that just to protect it, but it's there for now. It's not going to go anywhere or get caught in anything. So what I need to do now is get these pipes connected up. Okay, so what I've got here, this is actually a 25 to 25, 45 degree. If I trim this down and use this short joiner, okay, short 100mm joiner, then I can actually get that at the right angle, okay, without bending the hoses at all. And that might actually work. I might be able to leave that one like that. I'm worried about the oil leaking behind there, so I'll see if I can get a 135 degree sort of reducer, but if not, this will have to do. Okay, so I need that kind of sort of like that height. Okay, so from there to there, and then that literally cut halfway between the two. Okay. Okay. So then that goes like that. So let's get the clips on first. So how are we going to do this? Let's put the clips that way round and put that one there. Okay. Get that in. I'll try and make sure this joiner goes equally into each half. Right, there we go, that's looking good. Jubilee clip, another Jubilee clip on there. That goes there. Okay, that looks nice. I like that. And that there. Now we'll get a couple more clips. Okay, so that will go like that. Two more Jubilee clips there. Bit of a clip where we stick the screwdriver in, but right, okay. Looking good. Let's give that a little clean up. There we go. Brilliant. Okay, so that's the top pipe. That is the top pipe coming out into here, and then we need to connect the bottom one along and up into the duct. And before I do that, I need to have a think about the drain pipe. I think it's okay. I'll push on, and I will do that bottom one, then I'll do the drain, and then we'll put the rest of the duct back in. Okay, so this is the one that I'm going to be using. Okay, I'm going to take that off because that needs putting into the duct. And I need to get this rigged up. And again, we've got this far too long joiner here. That's how I think. So that goes there. Turned a bit. Okay, and then so that. See, this is where I've got a problem because these have to cross over. Now, what I could do is take that out and straight down. That's an idea. And then this one lower down. might work better actually. I've got to take this in above here, so if that went down and then another 90 degree, luckily I've got 3 of these left because I was going to put 2 here. What I'm going to do is get that attached onto the catch can. Okay. Right, and there's that ready to connect in. So the next thing is the vent pipe at the bottom. Alright, the vent uses an 11mm hose. It's actually a 12mm outlet, and I've bought a 12mm little ball valve thing. I'm going to get the hose for that. Okay, so this is the 11mm hose, and there's the valve. So I'll put that in like that. That's a nice snug fit, and then that can be just, well, it'll be like that. That's closed, and then like that is open. Okay, so that's to drain off the oil that collects. Now, this catch can actually, because the outlet is quite far down, there's not that much depth of oil that can build up. So it would be good to keep this hose as long as possible, because this adds extra volume to the amount of oil that can be collected. Okay, right, that drain pipe is now on the bottom of the catch can, and the little tap is just sort of dangling down. Let's see if we can get that. Yeah. Right, I'm going to try and show you that now. It's a bit dark down there. Okay, so this is what we've got. We've got the pipes. I need to connect this one with another 90 degree into the duct, which I'll fit next. I'm just going to leave the engine cover off for now because I'm going to be messing around with that thing over there. Okay, so we've got the can. We've got this pipe here, which you can just see. It is pretty dark. Hopefully you can see. Now let's see if I can try and put this. There you go. Rat oily now. Okay. And that just goes off down there, okay, with the little tap at the bottom. It's not hanging too low under the car, it's just sort of at the sort of subframe kind of level, okay, so it's not going to be rattling about on the sump guard. Okay, so what I'm going to do now, put the rest of the can together and then fit the ducting. Right, let's get this assembled. That goes in there. In there. That's on the cap or not. This thing keeps on tripping. Yeah, that's on. Right, nearly there. I need to just put this ducting back on now, and then I'm going to start the engine and see what happens. Clean up because it's really this nice new shiny one on. Okay, so that one then connects it to the duct over there. Now this joint here is the troublesome joint, which leaks oil, so it needs to be nice and tight. Right, there we go. And then that, so let's get this in here. Oh. Right, and then that goes onto there with a clip. Okay, so let's go that way. Come on. Come on, oh look at that. Wow. I'm pleased with that, that looks good. Just get this tightened, put the air filter back on, start the car, see what happens. I'll leave my duct adapter off for now. Right, please tell me this is going to fit. Oh, come on. Come on. Come on. Oh, I want that. Turn that one round as well. Okay. Right. This has got to go. Right. Something's making it a bit difficult to push in, but it's in there. It's very, very close here, but it is in. Something's rattling. I think that's what is that? That's the thread bit on the nickel there. So right, let's do this one up first. Right, okay. That, don't forget our little plug for the MAF sensor. I wish this box wasn't so wobbly, but at least with that there now it's a little bit less wobbly. Right, okay. It's in. Oh my goodness me, that was hard work. But it's in. And that's all pretty solid, that's nice. I have no idea if the top engine cover is going to refit or not. I'm not going to do that now. I'm going to clear everything away. I'm going to start the engine and see if it runs okay. Right, let's get everything out of the way. Okay, right, well that's it for part one. The catch can is fitted, and in part two I'll look at the improvements and look at the cam cover and look at taking this duct down here to the turbo. So until then, thank you very much for watching. I hope this video was useful. I'll see you in part two. Don't forget to like and subscribe. Thank you very much. Bye.